এটা রেকর্ড করছি কিন্তু
এ
রেকর্ড হবে এটা
ও
Okay.
আচ্ছা, ঠিক আছে।
Only few minutes will to complete the review of rates of reaction.
হুম
Can reach all level chemistry. This is one of the easiest and simple simple topic. Later on it will be in advanced, especially in A2. So from here you have to know these are the things in your syllabus you have. What are those? The effect of concentration, pressure, particle size, temperature on the rates of reaction, catalyst, effect of catalyst, then how catalyst increases the rate of reaction. Also, you have to know the industrial catalyst and the biological catalyst. That is called enzyme. Enzyme is the biological catalyst. Then
হুম
two investigations. You have to know experimental investigations on the rate of reaction. So you want to go in detail. The first one is rate of reaction definition, amount of products per unit time. Amount of product produced per unit time, or you can define it amount of reactant used per time taken, right? So unit depends on the data given. Amount is given in gram. Unit will be gram per cm cube or sorry gram per second or gram gram per minute. It depends on the data. How the data will be given, time and the amount. This way the unit will come. Okay. So we'll discuss the factors. The factors are concentration, pressure, particle size, temperature, and the catalyst. Let's go in detail. The first one is the concentration. With increasing concentration, rate of reaction increases. You know this one. Concentration increases means more particles, right? In unit volume, more collisions. Collisions means here collisions between particle to particle. Collision to the wall is not the effective collision. You won't get the product. If the collisions occur between the particles, the reaction will be faster. So in the diagram you look here, x-axis time and y-axis volume. We can consider here, we can measure the rate of reaction between calcium carbonate and hydrochloric acid. The first one, hydrochloric acid, is here 1 mole per dm cube. The second experiment you look here is 2 mole per dm cube. You see if you see 2 mole per dm cube, but calcium carbonate we are reacting here is constant mass, and the size and particle size are similar. So only with changing the concentration of hydrochloric acid. So greater the concentration of hydrochloric acid, rate will be faster. So actually we measure from the here gradient. We calculate gradient, right? So the tangent line, then gradient. You know this one.
Yes.
Tangent line, then gradient. So I think concentration is okay for you. The next
হুম
one is pressure. Pressure affect only the gaseous substance, right? With increasing pressure, rate increases. With increasing pressure means more particles in unit volume. More particles in unit volume. So more collisions, more effective collisions. So rate will be. This is quite easy, but you have to remember for liquid and solid pressure. If you apply pressure, they are almost incompressible. So no pressure effect for the liquid
অনেক
or the solid particle. Yeah, it has the greatest effect only for the gases. The next one, the particle size or the surface area. If you break down a big particle into the small one, more surfaces will be created, right?
Yeah.
So big particle has smaller surface area than its powder. So if you use calcium carbonate, normal calcium carbonate, just one particle, and if you use powder of calcium carbonate, in the second case, the rate will be high, right? The rate will be high. You can give another example, magnesium and carbon dioxide is produced with magnesium. How can it possible carbon dioxide will be made? Then maybe it's strong. Magnesium carbonate, we can call it magnesium carbonate. Powder and normal size magnesium carbonate with hydrochloric acid. Here, the magnesium carbonate is changes the surface area changes. One is lump of calcium magnesium carbonate, another one is the powder. Which one is powder? Red higher, right? This one.
Higher.
Yes, red higher. So last day you have studied. So next one, temperature. Temperature is a very good factor. Always rate increases. How the rate increases? Temperature increases the kinetic energy, right? So movement increases, particle will move faster. So more effective collisions, rate will be increased. So higher temperature, higher the rate. It is quite easy, I think. Then next one, catalyst. Beginning catalyst. Catalyst is an inorganic substance. Mostly in your case, we use transition element or the compound of transition element, right?
Yes.
Mostly industrial catalyst, transition element or compound of transition element. It creates alternative way. The red broken line you see the diagram. It creates alternative way that has a lower activation energy. The red color you see here, activation energy reduced. This amount reduced, right? So speed will be faster. Rate will be faster. Rates of reaction will be increased if we use catalyst. How? It creates alternative way being unchanged chemically. Are you getting my point?
Yes, sir.
Unchanged and chemically unchanged. Physically it can be changed. This is the function of catalyst actually. So industrial catalyst you have to study in your whole course. Actually, ammonia making you have studied, right? And iron is the catalyst. In ammonia making we use nitrogen and hydrogen chemical to react and make ammonia. And iron is the catalyst. This is Haber process. Sulfuric acid manufacturing in contact process, we use sulfur dioxide and oxygen, vanadium pentoxide. This is the compound of transition metal, right? But the first one was transition metal only. Making nitric acid, we use platinum. Like, similarly, making margarine, you have studied in alcohol chapter. No, alkene chapter. Sorry, alkene in alkene chapter. You make vegetable oil for margarine. This is the addition reaction, right? Nickel is the catalyst. Nickel is transition metal. So here we can make a small summary that is for industrial catalyst. We use transition metal or transition metal compound. The next one also you have to know catalyst regarding the biological catalyst, which acts in living cell. You have studied biology.
Yeah.
Also, in alcohol chapter, you can make ethanol from glucose using yeast. Yeast is the biological catalyst. This is enzyme acts in living cell. This is important, very, very important for you. Investigation, the rate of reaction. When you say here reactant, what are the reactant? We want to take here very simple example. Say calcium carbonate, solid. Okay. And another reactant is hydrochloric acid. These two will react and make what's the gas? Farhan? Gas is here carbon dioxide, calcium chloride, and water. We are writing only the gas here. Gas will be measured as we can measure the time. Time in the x-axis and the volume of the gas in the y-axis. Yes, we are taking two reactants here, calcium carbonate and hydrochloric acid. They react and make calcium chloride and water. This will be present here. And another product is the gas, carbon dioxide gas. This will go to the gas syringe. It will be collected. When the reaction will be started, you have to start on your stopwatch as well. So you will get time as well as the volume. And the last point is here, no increase of volume, the same, no more product is produced. And here the initial rate is the higher. If you draw the gradient, you can find the rate from here, right? The gradient. Understand?
Mm.
This is the rate. So if you given calcium carbonate and hydrochloric acid, how you will investigate the rate? Your concern is you will measure the time as well as the volume of the gas in the gas cylinder. And then if you draw the diagram, the curve, from the curve you can draw the transient. From the transient you can find the gradient in the rate. Another
Sir,
way, yes,
can
question.
you repeat?
Yes, this
Can you
one,
repeat? Yes.
the whole thing, the whole thing.
No, not the whole thing. Like from the part of gas thing.
Yeah, volume of gas you will measure in the gas cylinder and the time in the stopwatch, right? The corresponding time you will get the volume. Then you
Okay.
draw the graph. From the
Mm.
graph, if you find the gradient, if you calculate the gradient is the rate. Understand?
Yes.
The question is here, how will investigate the rate using this experiment? Another one, you look here. The total mass is given here. We are giving here zinc and hydrochloric acid. They will react and make hydrogen gas. This will be go off slowly through the cotton ore, right? Now, from here, total mass is given. Gradually, mass is decreasing because of gas product is going on, right? So from here, if you calculate the gradient is the rate of reaction. This rate will be minimum because negative because we are calculating the remaining mass actually, total mass and the remaining mass. The product is going out. Another way we can find out hydrogen peroxide decomposition, but not we are discussing. This will be needed for your paper 4 actually. It is an H2O2 gas, hydrogen peroxide gas decomposition. Different catalyst, different speed. So we have already discussed about catalyst. The main thing here, correction theory. In a chemical reaction, the molecules or the reactant must collide each other to take part in reaction, right? If
Mm.
there is no collision, no product. If the get product, this collision is called effective collision. Understand? So,
Yes,
uh,
bro.
if the particles do not collide each other, we won't get product, right?
Okay.
The collisions means here effective collision. Effective collisions means collide between the reactants and we're getting the product. We are
Mm.
getting the product. The collisions are called effective collisions, and the collisions to the wall is not effective collisions. We are not getting product if the molecule hit the wall, right? So I can make you the summary of this chapter. The first part is rates of reaction. You have to know the definition, then factors, concentration, pressure, particle size, temperature, and the catalyst. And detail about concentration increases, rate increases. There is you know clearly. Pressure increases, rate increases. Particle size increases, rate decreases. Particle size decrease, surface area increase, rate increase. So you have to clear the concept. Temperature, always, always, always. You have to remember this one. Temperature increases, rate increases. In presence of catalyst, rate increases because catalyst create creates alternative way that has the lower activation energy. And the I have given here example, right? Different catalyst of different industrial catalyst, different processes used in your course. And the next one, biological catalyst and investigation of rate of reaction, which I have discussed. It is very very important for you. You have to remember it. Uh, so, in a nutshell, this is your slides, right? So easily you can do it. Then investigation of rate using the mass, decreasing mass, and the last one collision theory. So this part is okay. This part is okay. I am closing the recording option. Then I'll start another one.
Okay.